we've got a quadratic on the top, and we've actually got a cubic on the bottom with a repeated factor. Okay, so this is actually moving up 2 levels of difficulty at once. If I were to write this like this is perfectly correct. I could write the bottom as 1 minus 2x times another bracket of 1 minus 2x times 2 plus x. And you might think that just as this one here, where I had 2 brackets on the bottom, okay, I had to find the brackets myself, went into 2 fractions with each bracket used once, you might expect this one, given that it is the same as that, to go into something a over 1 minus 2x using the first bracket, plus something else b over the second bracket, plus something else over the third bracket. And if these were all different factors, that would be the correct way to go. All right, there isn't an example on this page where we've got 3 different factors, but when there are 3 different factors, this would work. But with these 2 factors being the same, with this being a squared bracket, we can see this isn't going to work in quite the same way, because this is just a number over 1 minus 2x, and this is just a number over 1 minus 2x. So this is really 2 fractions of the same type. In fact, if a was 1 and b was 2, then 1 over this factor plus 2 over this factor is just going to equal 3 over this factor. This is not really counting as 2 fractions. So what turns out to work for these, I'm not going to prove why it works, but we'll see it does work for this one, is that if you've got a repeated factor, a squared factor, then the first time you use it, you do use it as normal. But for the second one, to make it different, so it can't just be straightforwardly added to the first one, as if it was only 1 fraction, we have to use the squared on the second one. So a squared bracket appears once as itself and once as itself squared. And this factor that isn't squared just appears normally over here. So we will be able to find a, b and c that work here. Without that squared on, we wouldn't be able to make it work. Okay, so this business of actually writing out the 3 factors actually isn't particularly helpful for this one. The squared factor has to be treated differently in this particular way. All right, but what we do next is just the same. Okay, so this is where, if you followed the previous example, it would be really good if on a scrap of paper, pause the video, say what you think I'm going to get for 9 plus 4x squared on the next line. Okay, go on, pause the video, fill it in. Have you done that? Are you back? Okay, all right, what I hope you got was this. I hope you said, I'm going to multiply by all of this stuff on the bottom. So when I multiply by, actually this is the hardest one, I'm going to go to the second one first, okay. So when I multiply by this bracket squared, it's just going to cancel this bracket squared on the bottom, giving me b, but I haven't yet used the 2 plus x, so I'm going to get b times 2 plus x. And then moving on to the third term, okay, when I multiply by the 2 plus x, this one here, then that's going to cancel the 2 plus x on the bottom, leaving me with just c. But I haven't used the 1 minus 2x squared, so 1 minus 2x squared after the c. Okay, coming back to the trickiest one, the a one, what will happen when I multiply by the 1 minus 2x squared? Well, it will certainly cancel this, but this isn't squared. So the 1 minus 2x that didn't cancel is still going to be there. And the 2 plus x is definitely not going to be cancelled, so that'll be there too. Just about squeeze it in. So when you do these, okay, the one where you had just a single copy of that bracket is going to get a single copy of both brackets after it. The one with the squared on the bottom, that's going to be completely cancelled, and I'll just have the odd man out bracket here, and the one with the odd man out bracket is going to have the squared bracket after it. So that's always the same pattern. And just as we did before, we're going to substitute in the smart values of x. So what might be smart values of x? Well, 1 minus 2x could equal 0, or 2 plus x could equal 0. So let's choose one of those. 2 plus x equaling 0 would be x equals minus 2. So if I put that smart value of x in, this is going to be 9 plus 4 times minus 2 squared. And minus 2 squared is plus 4. Minus times a minus is a plus. Equals, okay, well, taking x to equal minus 2, this is a times a bracket I don't know times a bracket that equals 0. So I don't really care about this bracket. This one equals 0, so I'm going to get 0 a's. And this is going to be b times a bracket that's forced to equal 0 by x being minus 2. So it's going to be plus 0 b's. But this one here, c times 1 minus 2x squared, okay, if x is minus 2, then 1 take away 2x, be careful with minus signs, that's 1 plus 4 squared, so this is going to be plus 25c, because 5 squared, 1 minus minus 4 is 5, square that you get 25. So that means that 25c equals whatever the answer to 9 plus 4 fours is. Oh, that's 25. So actually c turns out to be 1. That's all very, very nice. Okay. Right, have I got any more smart values of x? Yes, I can make 1 minus 2x equal 0. For 1 minus 2x to equal 0, x has to be a half. Okay. So I'm going to have 9 plus 4 times, and x is a half, so I need to do a half squared, that's a quarter. So that's not going to be too bad. 4 times a quarter is a whole number, that's quite nice actually. Once again, I've got a factor of 0 here times the a, so I'm going to get 0a again. This time b is going to be multiplied by something that's not 0. 2 plus a half is 5 over 2, so plus 5 over 2b, plus, and c, well, this bracket is 0 again. 1 minus 2 times a half is 0, so I'm going to have plus 0c. So this is telling me that this is 4 times a quarter is 1, so this is 10. 9 plus 1 is 10, equals 5 over 2b. So to find b, I double it and divide by 5, so that's b going to be 4. And I know what b is. So now all I don't know is what a is. But I've run out of smart values of x. Okay, which is not a problem at all. Actually, you don't have to use smart values of x. You can use stupid values of x. You can use values of x that don't do anything in particular, and that leads to simultaneous equations. If I chose x to be 21, I'd get some number equals some number of a's plus some number of b's plus some number of c's. If I choose a different value of x, I'd get another equation, and as soon as I've got 3 equations, I can solve simultaneous equations. Okay, it's just that the method of putting in smart values of x saves you that bother. Okay, so but when you run out of smart values of x, you've got to put in the next easiest value of x, and normally the easiest number to substitute into any formula is 0. Okay, but I could use 1 here, I could use 7, I could use 162 if I was stupid. It would still work, I'd just have bigger numbers. But using 0 is very easy to do the sums. 9 plus 4 times x squared when x is 0 is just 9. Okay, equals, alright, so a times 1 minus twice 0 is going to be 1, but 2 plus 0 is 2, so this is going to be a times 1 times 2. Okay, these dots mean times if you've not seen them before. Plus b, okay, times 2 plus 0 is 2, so this is b times 2, and this is c times 1 minus twice 0 is 1, so this is c times 1 squared, which is 1c. So simplifying this, I get 9 equals, this is going to be 2a. When I get to these others, remember I found b and c already. b is known to be 4, so this is going to be actually 4 times 2, which is 8. And this is c times 1, so this is just c, and c is 1, so it's plus 1. So 9 equals 2a plus 8 plus 1, so lo and behold, 2a equals 0. So in this particular one, it turns out that a is 0. Okay, that can happen. So the answer, all I've got to do now is write out the answer. This is the answer, but I've got to put the values of a, b and c in. Okay, so the answer is 0 over 1 minus 2x, and of course you could actually leave that one out, plus b, which is 4 over 1 plus 2x in a bracket squared, plus c, which is, c is 1 over 2 plus x. So this is your answer, and that first term, if you miss that out, then that's not a problem. Okay, so that's how you do partial fractions.